This video is all about switch statements, and sadly, that has nothing to do with Nintendo, which the video title already told you. Okay, almost nothing to do with Nintendo, because our examples definitely have something to do with Nintendo. Switch statements are very special if-else blocks, where you take in a value of some kind, usually an enum, then try to match it to one of your if checks, then do the related logic. It's a bit different than just writing if value equals this, else if value equals that, etc., but we'll kind of get back to that in a little bit. So to start, we're going to download the starter code in the description for where this code picks up. If you've been watching my series thus far, there isn't any concepts I haven't talked about yet. So go ahead, pause here, download it, and get a feel for the classes I've added. As you can see, we have created a few new things since my advanced classes video. Primarily, the Eevee class, a class for each of its evolutions, and an enum for each of the evolution stones, and a few fake ones. And lastly, we've also extended our evolvable interface to be two different sub-interfaces, level evolvable and stone evolvable. Level evolvable is the same as evolvable was before, but stone evolvables takes in that evolution stone enum as a parameter. Now, we look at our Eevee and see it implements the stone evolvable interface and overrides the evolve method. I'm also using an if-else-if block with if stone equals evolution stone.firestone, return Flareon, else if takes in Thunderstone, return Jolteon, etc., etc. And then eventually doing else return this, where the else just says if no stone works, return our current Eevee. Now in our main method, we're going to do Eevee equals new Eevee. Then do Pokemon evolved equals Eevee.evolve evolutionstone.waterstone. Then evolved.sayname. When we run it, we'll see that we get Vaporeon. If you try Firestone, you'll get Flareon. And Sunstone returns Eevee because that's not a valid stone for Eevee. Okay, so we should see a very strong pattern emerge. Everything is input equals type, which is where switch statements excel. So above our if block, we're going to create a new version to replace it. We're going to use a shiny keyword switch, then a space, open close parentheses with our input inside of it. Then add some squiggly brackets. Next, we're going to go inside them. We're going to tab once and then add another shiny word, case, which means what we want our input to equal. Then we're going to do waterstone, new line, and then we will return vaporeon.builder.name vaporeon.level this.getLevel.build, same as in the if statement. Now pause here and copy this format for all of the other else if conditionals, but don't do the else just yet. I'm going to handle that one with you guys. Now our code is almost complete. All we have left is that else block. Well, those are called default in Switchland. So the last thing we're going to do is add default return this. This is great and works exactly like our if statement block below. So just go ahead and delete the if block. We'll never hit it. Now we're going to run this again and we'll see that we still get Vaporeon. Now we're going to make a few tweaks to see how else our switch statements can work. First, let's remove our default and then just return this outside of the switch statement. It'll still run the same as before, so passing in Waterstone returns Vaporeon, passing in Sunstone returns Eevee. Now we're going to make a few changes just for the sake of learning more about switch statements. Let's create a new variable at the top of the method, Pokemon evolution equals this, which will start with our Eevee value, and then at the bottom we're going to return evolution. Now, instead of returning the evolved forms immediately, let's set them to be the new value of evolution. So we'll have evolution equals Flareon, equals Vaporeon, etc. So if we run this, we'll see that we get Sylveon? That's not right. What happened? We passed in a Waterstone. Well, switch statements differ from if statements in that they aren't looking for an exact match, but rather a first match. The moment they encounter a case where the result is true, it executes every other case below it. But that seems kinda crappy. How are switch statements even usable? It's Joy-Con drift all over again. Well, there's a new shiny word that we haven't used yet, but are really useful here and in our loops. Break. We'll see how useful they are in loops later, but in general, break just means stop processing here and exit what we're doing. So add a break after each of our evolution equals lines, run it again, and now we finally get back our Vaporeon. Break lines are important and will be used almost every time you have a case. But there might be some interesting use cases where if you get one switch case, you might want to run another one right after that. In that case, group them together in the switch declaration and let them cascade into each other until you're ready to stop executing. Then add a break in that last case. You can do this several times throughout a switch statement, just make sure that your groups are properly ordered. If you've been watching since the start, you can see why I didn't teach these during regular conditionals. They're way more complex and are much easier to learn once you have a bit more practice. Also, enums are one of the most common users of switch statements, so that's why this is a fast follow on the advanced classes video I did. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.